Okay, turn to page 67 in your packet. This is your warm-up. We will pause the video here and give you about 8 to 10 minutes to do all 4 problems, and then we will unpause and you will see me do the answers. Okay, so for number 1, for the amplitude, it is the distance from the maximum to the minimum divided by 2, which is 5. The period, 1 rotation from the beginning to the end is pi. If I write a cosine equation, the phase shift is to the right pi over 4, and there is no vertical shift. The midline is at y equals 0. So our function is y equals. You need a y equals for an equation. If you don't write a y equals, you will lose points. 5 cosine. Then we need our b value, which is 2 pi over the period. So that's 2. X minus pi over 4 for to the right pi over 4. For number 2, the amplitude is half that distance again. So if it starts at 3 and is a minimum of -1, the amplitude is 2. The period is 2 pi from the beginning of a pattern back to the beginning. Because it's a cosine function, there is no phase shift. And the midline for the vertical shift is at +1. So we'll say up 1. So our function is y equals 2 cosine, I need my b value, which is 1, so just x, and then +1. You don't need those parentheses around x, but that is a way so you can clearly see the +1 is up 1 and not a phase shift to the left or right. Okay, for number 3, now we are doing a sine function as the parent. So the maximum here is at 5, and the minimum is at 1, it looks like. So the amplitude is 2. The period is 6 pi. Because it's a cosine, so sine function, so the middle going up is here. So that's to the right, 9 pi over 2. The vertical shift is up 3. So our function is y equals 2 sine, I need the b value, that's 1/3. So 1/3 x minus 9 pi over 2 plus 3. And then lastly, for number 4, the amplitude is a half. If you look at that y scale, it's by, the minimum is at -1/2, and the maximum is at +1/2. The period, all right, so one pattern, if it starts here in the middle, it gets back over here at 2 pi over 5. Because we're going to do a sine function, I need the middle going up for a positive sine graph. So that's here, which is going to be right pi over 5. Vertical shift is none. So y equals 1/2 sine. Now b is 2 pi over 2 pi over 5. So to simplify that, we are going to multiply by the reciprocal of the denominator and get 5. To the right, pi over 5, and no vertical shift. Now page 68 in your packet is a source for you. It goes through all the different pieces of writing the equation of 68 and 69. Now page 70 is where we are going to do some more practice with the word problems. So page 70 and 71 are technically your homework. So I'm going to do them now for you on video so that you have the solutions. Anything we don't finish in class if the bell rings is for you to finish for homework. All right, so number 1, a ball on a string is swinging back and forth from a ceiling as shown. Okay, good. I'm glad A is sketch a graph because that is the only way I know how to write an equation. The x-axis is time, and the y-axis is going to be distance in centimeters. And then let's see, at 0 seconds, we're at 140 centimeters, which is the highest. At 3 seconds, we're at the minimum of 20 centimeters. And then at 6 seconds, we're back to the maximum of 140. So if I forgot a point there. Connect my graph, I see my nice cosine function. So since B is write an equation, so A is our amplitude, and that is the maximum minus the minimum divided by 2, and that's going to give us 60. I'm going to choose a cosine function since our graph starts at a maximum, and that way we don't have a phase shift. B is 2 pi over 6, which reduces to pi over 3. And our vertical shift to the midline is the max plus the minimum divided by 2, which is 80. So now for t equals 4 seconds, or that's, in my case, I used x instead of t, we're going to substitute 4 in for x. So 4 times pi over 3 is 4 pi over 3. And now you have a choice. You can use your calculator to evaluate that. I remember my special right triangle, so I can get an exact value for 4 pi over 3. So cosine of 4 pi over 3 is -1/2. So this is -30 plus 80. We get 50 centimeters. So for D, we have to find the first time the ball is at 50 centimeters. So what we're going to do is set the equation equal to 50. And this would be a nicer one to use the calculator for. What we're going to do is we're going to put 50 in y1 and the other equation in y2, or one of them in y1, the other in y2. It does not matter which. And I'm going to insert a picture of my calculator here so you can see how I typed this. You have to make sure you're in radian mode because of the pi over 3. Okay, so there is how I typed the y1 and the y2 in the calculator. I make sure to do all those parentheses for the cosine part so that the calculator knows I want the pi over 3 and the x inside the cosine function. So now we have to find what x is going to be. So I'm going to go to the graph, but you have to set your window correctly. And actually, we can use our original picture here to help us set the window. Your y maximum should be more than 140, so make it like 200, something close. And then your x maximum, I don't know, I'll make it 10, a little more than 6. I can see a full rotation. And then make sure your minimums for x and y are, you can do 0 or a negative. So I'm going to set my window and then graph it. And then once you have the picture of your graph, like I have, you have to do second trace. Choice number 5 is intersect. And put your cursor close to the first point where the two graphs intersect. So you're going to arrow over, and you want your cursor, the little blinking X, closest to this point, and then hit enter 3 times. And it's going to give you the answer at the bottom that X is 2. So that's 2 seconds as an answer. Okay, page 71, our second question. Sarah is riding a Ferris wheel. Her sister, Carrie, starts a stopwatch and records some data. H is her height above the ground. Carrie notices that Sarah is the highest, 90 feet, at 4 seconds, and at 8 seconds she's at the lowest at 10. So let's draw a little graph because I cannot do these problems without a picture. It is easier for me. So at 4 seconds, she's at 90. At 8 seconds, she's at 10. So that means it's going to be another 4 seconds to her to get back to the top. So I see my trig graph. So amplitude is 90 minus 10 divided by 2, which is going to be 40. I'm going to choose a cosine graph because I can see exactly where the maximum is at. My b value is going to be 2 pi over this length, so the period is 8. 12 minus 4 is 8, so that's pi over 4. The maximum shifted to the right 4, and the midline is halfway between 90 and 10 at 50. What will Sarah's height be at 10.5 seconds? So I'm just going to use the calculator now. We're going to put 10.5 in for x. Make sure you're in radian mode. And again, I'm going to show you how I type this in my calculator. So here's my calculator, and I get, an answer of 65. And it says 3 decimal places, so 307 feet. So in the calculator, I put parentheses around pi over 4, parentheses around the subtraction, and then a big parenthesis for everything that's inside the cosine. Determine the first 2 times when Sarah's height is 75 feet. So again, I'm going to go to my calculator in the y equals and put in this original function. I will show you the parentheses that I type again with another picture. We're going to set our window using this little picture to help us. Let me move this. So for the window, I would do the y minimum is 0. The y max, I'll do 100. The x min, I'll do is 0 again. And the x max, I'll round up to 15 so I can see a little bit past that 12. So here's what I've typed in my calculator. You have to make sure that the y2 is the 75, which you want to intersect with. Then I'm going to go to the graph. I'm going to let the calculator think and draw the cosine function, and then it's going to draw the 75. And because we want 2 times, we have to do intersect twice. So we're going to do second trace, choice number 5, arrow to the first time the graphs intersect, and hit enter 3 times. And the time should be 2.8596. Oh, so we got to round that to 3 decimal places. Let me get some space here. So the first time that this happens is 2. And then 8596 rounds to 860 seconds. And then the second time it happens, you have to hit second trace, intersect is choice 5, arrow over to the second intersection point, hit enter 3 times, and you should get 5.140 seconds. Okay, last but not least, number 3. The ocean. Oh good, we have to sketch a graph again. The low tide is at midnight, so that's 3 meters on the y-axis. High tide, 30 So 5:30 a.m. is like 5.5 hours past midnight. And that's the high tide at 8. So then low tide is going to happen 5.5 hours later. So 5.5 plus 5.5 is 11. It's to get back at low tide. So to write our equation, amplitude is max minus minimum divided by 2. I'm going to pick cosine. B is 2 pi over the period. Since I picked cosine, I'm going to go to the right, 5.5 for the phase shift. And then the midline D is at 8 plus 3 divided by 2. Don't freak out that there's so many fractions. It's okay. Suppose the ship requires at least 3 meters of water in depth to dock after midnight. Determine the earliest possible time that it can dock. So we're going to go to our calculator again. In y1, put the equation. In y2, we're going to put 3. So I will show you a picture of how I typed that. So here's my equation and the graph I got. For the window, again, I used my picture. For x, I went 0. I think I left it at 15 from the prior problem. And then I did for the y, 0 to 10. So because the minimum is 3, I could technically draw that on this graph. And we want to know the times after midnight the ship can dock. Well, it technically could dock at midnight, because that is when the water is exactly at 3. But if that's not if it wants to be after, let's find this time over here, which will be 11 a.m. That's the next time we're at our minimum. You could do second, trace, intersect, arrow to the spot, hit enter 3 times. This is considered 12 a.m. And you are done. And you are done your homework. Good job.